Hello everyone, hope you're doing well. In this video, we'll look at the next topics of rotational motion. And the topics are torque. We'll try to understand what is torque and do a few examples on that. And then equilibrium of rigid bodies. We'll see what do we mean by equilibrium of rigid bodies and what are the conditions required for that. Let's first understand what is torque. Torque is a measure of the force that can cause an object to rotate about an axis. So what is torque? It is the measure of the force that can cause an object to rotate about an axis. So whatever force does in linear motion, the same thing torque does in angular motion. So I can say torque is a rotational analog of force. Now what does force do in linear motion? If force is applied on a body of constant mass, it accelerates the body. Similarly, if torque is applied on a body of constant moment of inertia, then it will produce angular acceleration in that body. So I can say if tau is the torque applied on the body, then tau is proportional to the angular acceleration alpha produced in the body if moment of inertia of the body is constant. Now how do we find the torque? Let's look at this particular situation. We have a rod. I'll assume that this is the point where it is fixed, that is, this is acting as an axis. Now we see that force F is acting at an angle theta to the bar. Now what I do is I find the two perpendicular components of the force, one along the bar and the other perpendicular to the bar. Now F cos theta, which is acting along the bar, cannot rotate the bar. Only F sin theta can rotate the bar. So I can write the net torque acting on this bar is tau equal to F sin theta into R. Right. Where R is what? R is the distance between the axis and the point of application of force. Now in vector form what we can write? We can write tau equal to R cross F. So the net torque acting on the body is the cross product of the position vector of the point of application of force with respect to the axis of rotation and the force applied on the object. So tau equal to R cross F. This is how we find the torque acting on the body. Now, what are the cases under which the torque acting on the body would be zero? So we have seen tau equal to R cross F. R cross F, or in magnitude, I can write tau equal to RF sin theta. So I can say tau equal to 0 under what condition? If theta equal to 0. Now, what do I mean by theta equal to 0? If theta is equal to 0, then the force would be acting along the bar, or it would be along the axis. So if a force is acting along the axis of the body, then the torque produced by the force is 0. So I can say a force acting along the axis does not produce torque. Fine. So this is torque. Torque is given by cross product of R and F. Now let's look at how do we find the direction of torque. Torque is an axial vector. Like all other rotational quantities, torque is also an axial vector. That is, it is directed along the axis of the body. Now how do I find torque? We have seen that torque equal to how much? It is R cross F. That is, it is perpendicular to the plane of R and F. Now any cross product, the general rule of finding the direction of cross product is right hand thumb rule. So stretch your fingers of the right hand, and turn them from the first vector to the second vector. Like if you can see it, if I have my fingers like this, I curl my fingers from first vector to second vector like this. Then the direction of thumb would give the direction of torque. Here what will I do? I'll first point my four fingers along the direction of R and then turn them towards force. Now whatever is the direction of thumb, that would give us the direction of torque. So here in the figure you can see that if this is the direction of R. So I curl my fingers from R to F, then I'll see that my thumb would be pointing upwards. So the direction of torque would be upwards. So in this case, this is way. Not only this, anywhere if we have cross product, we can use that method to find the direction of the result that we get due to cross product. Now, by convention, we take anti-clockwise direction of torque as positive and clockwise direction of torque as negative. So we can say counterclockwise torque or anti-clockwise torque is taken as positive, and clockwise is taken as negative, right? So for example, let's say I have a disc of radius r. Now I'm having a force F1 acting like this and a force F2 acting like this. Then torque due to F1 would be equal to how much? Like perpendicular distance is r and force is F1, so it is r into F1. Now is it positive or negative? You can see that this torque F1 about the central axis is trying to rotate it anti-clockwise, so it is positive. Now torque due to F2 is acting like this. Again the perpendicular distance is r, but this is rotating it in clockwise direction, so its torque can be written as minus r. So in this way, depending on whether it is creating clockwise rotation or counterclockwise rotation, or the tendency of creating clockwise rotation or counterclockwise rotations can be given the signs as positive if it is counterclockwise and negative if it is let's say clockwise. After this, we look into equilibrium of rigid bodies. So what is equilibrium of bodies which are in linear motion, or under what condition we say that equilibrium of a body is in equilibrium under linear motion? If the net external force acting on the system is zero, then we say that the body is in equilibrium. Now in case of rigid bodies, a body is in equilibrium when net external torque acting on it is zero. Now what would happen if net external torque acting on it becomes zero? First thing is the linear acceleration of its center of mass is zero. Now the linear acceleration of center of mass is zero under what condition? If net external force acting equal to zero. Its angular acceleration about any axis is zero. This is under what condition? Net external torque is zero. So the condition required for a rigid body to be in equilibrium is what? The net external torque acting on the body should be zero and the net external force acting on the body should be zero. Now why do we study about this rigid body equilibrium? Now let's say I have a situation that is shown here. Now I want to check how much weight this setup bear. So for that I need to check what is the I go for application of rigid body equilibrium. Like you will see that if tension here is T, now length, let's say length is L, then this weight is mg, anyhow it is given as 300. Now what are the torques applied? What are the different torques that are coming into picture? Now we have torque T acting, the total length is L, I'll take this as L by 2 and this as L by 2. And weight of the bar, I'll take weight of the bar as capital M, m0 into g. These are the forces acting. Tension acting here is T. Weight of the hanging mass is mg. Weight of the bar is m0 g. Then what is the torque? I can say torque due to tension is equal to how much? T into L by 2. This is anyhow perpendicular. I can write T into L by 2. Now is it producing clockwise torque or anti-clockwise torque? We can see that it is trying to rotate the body like this. So it is anti-clockwise torque. Now similarly, torque due to m0 g. What is torque due to m0 g? That is the weight m0 g, and what is the perpendicular distance? L by 2. This is the perpendicular distance from the axis, that is L by 2 cos 45. So I can write m0 g into L by 2 cos 45. Now this is producing a clockwise torque, so a negative sign. Now torque due to weight, it is mg into L cos 45 If you look at the perpendicular distance would be from here to here. So that is L cos 45. Again, this is also clockwise, so negative. Now, for this system to be in equilibrium, the sum of the forces torque should be 0. So T into L by 2 minus m naught g into L by 2 cos 45 minus mg into L cos 45 should be equal to 0. Solving this, look, taking the quantities which are known, I can find the unknown quantities. Like I can find out the tension. Now, if there is a maximum value of tension given, then I can find what is the maximum weight that can be hanged safely here. So in this way, equilibrium of rigid bodies helps us in solving many real life situation or real life problems. Let's look at a small example to understand this concept of equilibrium of rigid bodies in a better way. Let me take a long rod, or in fact I'll say a tree trunk which is being carried by two people. Now there is one person who is holding this tree at the edge, and there is other person who is holding the tree slightly inside it. Let me give the values. Let's say this whole length is 20 meters and he is holding at a distance of 2 meters from the edge. I'll call this person as A and this person as B. Both of them are on floor, horizontal ground. And I'll assume that mass of the log is some 40 kilograms, right? So about the center, mass of the log will be acting about the center, the weight will be acting in the downward direction, that is equal to 40 times G. Let's say force applied by A is FA and force applied by B is FB. Now I need to find what is the force applied by A and B. If I take into consideration the equilibrium of linear motion, then the net force would be 0. So total upward force should be equal to total downward force. That is one equation that we get. Now I'll look into using the equation of torque. So for using equation of torque, I can take any point as axis because angular acceleration about any point should be 0. I'll take this point O as axis. Now about O, torque due to FA is 0 because it is acting along axis. Torque due to 40G is clockwise and torque due to FB is counterclockwise. So I can say FB into how far it is, total distance is 20. So he is applying the force at a distance of 2 meters from the edge. So 20 minus 2 should be equal, or I'll write minus 40G. 40G into, where is the center of mass of the bar? It is at 10 meters from the edge. Should be equal to 0. So from this, what do I get? Force applied by B will be equal to 40G. I'll take G as 10 meter per second square into 10 by 20 minus 2, that is 18. So force applied by B is how much? We have 4,000 by 18 Newton. So this is the force applied by B. Once we know force applied by B, I can find force applied by A. So what is force applied by A? I need to find it. So force applied by A would be equal to how much? Force applied by B minus 40G. I'm sorry, it should be the other way around. 40G minus force applied by B. That is 400 minus 4,000 by 18. So that becomes, and in this way I can find what is force applied by A and force applied by B by using the method of equilibrium of rigid bodies. Fine. So this is what is there in torque. We have seen what is torque, how do we find the magnitude of torque, how do we find the direction of torque. Then we have seen what is equilibrium of rigid bodies and what are the conditions under which a rigid body is in equilibrium. And then we have seen an example to understand how this concept of equilibrium of rigid body helps us solving some real life situations. Hope you could follow this. Thank you very much and keep watching Get My Class videos. Thank you very much.